So now, okay, in this video, okay, we will see how the behavior of this RL, RC and RLC circuits. Uh, so that is called as a transient analysis of RC, RL and RL circuit. Especially it is dealt in a network theory or circuit theory. I will take one simple example. Consider one resistor and capacitor which is connected with some battery source. With the switch, okay, we have one switch here, K. In the circuit shown in figure, the switch K is closed at T is equal to 0. With capacitor uncharged, find the values of I, di by dt, d square I by dt at T is equal to 0 plus. The current flowing after closing the switch. First derivative and second derivative. This is all after closing the switch. And what are the values of the V? 100 volts, R is of 1 kilo ohm and C is 1 micro. Yeah, so we'll see how to solve this. And when we return a KVL for this circuit, R into I plus 1 by C integral of I dt is equal to V. This is the KVL around this loop. And T is equal to 0 plus when we closed it, suddenly when we close this switch, when we suddenly close it, capacitor acts as a short circuit, Sudden changes, capacitor simply it will be shortened here. So this entire, the voltage across this capacitor, this term is going to be 0. It is Ri of 0 plus is equal to V, or I of 0 plus is V by R, that is a point. This is about the I of 0 plus. Now we have to determine first derivative and second derivative. This is the KVL, then differentiate with respect to T, that is R, di by dt. It is an integration, and when we differentiate with respect to T, it is simply I by C. This V is a constant, it is a 0. And now we'll substitute the initial condition R di by dt at 0 plus, plus I of 0 plus by C, 0. Only we have to determine the di by dt. Remaining term, I will take it right side here. Minus I of 0 plus by R. This R is also I transferred here. This term will come to this and numerator. If it is a numerator, it comes to the denominator. Then I of 0 in the previous we determined 0.1. This is the 0.1 ampere. R value is 1 kilo ohm and 1 microfarad. The simplification, it is a minus 100 ampere per second. Next, we'll go for a second derivative, that is a d square I by dt. Equation, first derivative and simplification. This is a simplification. That term I have written here. Again, differentiate with respect to t. d square I by dt square is equal to minus 1 by rc di by dt of 0 plus. We know these two values and di by dt. Di by dt is minus 100. Minus 1 by 1 kilo, 1 micro. These are the resistor and capacitors values into minus 100. And this minus 100, this is the 1000. Simplified. Then numerator, denominator we have 10 into 10 to the power of minus 6 or 1 into 10 to the power of minus 5. When we take it into the numerator, it is a 1 into 10 to the power of 5 ampere per second square.